Hello everyone, Don here with the next update on the War Corsair project. As you all know, I got the thing all taxiing last week, and before I left the airport I pulled the tailwheel assembly off. So this past week I've been working on this thing, trying to make it a steerable tailwheel. So what I first started advantage to do is I took this main body and I chucked it up in my lathe and I cut this down. Because it was kind of up like this, it was in the way, and trying to put a swing or a control arm horn on this thing, this was in the way. So I machined that down, I machined this edge here true to the bore, and then I cleaned up the bottom of the bearing flush to the bore, parallel perpendicular to the bore. Okay, then the next thing you can see I did here, I cut this little window out, that little notched out section right there. That dip, that is going to be the part of this setup that allows the steering horn to disconnect from the wheel here. The yoke assembly and this will decouple from the horn. Okay, because this is a retract gear, the retract mechanism hooks to this thing here. You got two legs that stick up like this, and then they go up and they fold up. They're hinged up here on this end, so it folds up like so. So that's right here in the way. So a normal horn like this wouldn't work because it will hit this bar going up here, this retract mechanism. So I can't use a dual horn. Okay, so what I got here are some pieces and parts that I just made up this weekend. This is the horn, single horn. This hole here I'll make the size when I figure out what size I want. But essentially this goes over here, slips down on top of this shaft, and then that hole lines up with this notch under here. Okay, and then what I do now is I got a 1/4 inch ball bearing here that goes in this thing, just like so. There's a ball bearing in there. That ball bearing is a 1/4 inch. I'll get this thing back down. It moved, sorry. I can't find my tripod. I took it with me last weekend to make the video, threw it back in the car, brought everything home, took it out of the car, and now I can't find it. But okay, as you can see here, that ball bearing rides inside that little groove. And when it comes over to here, you've got between 20 and 30 degrees of travel from center. And then what happens is that bearing pushes up, as you can see, rides up on top of this and follows it around now. And that bearing's a 1/4 inch ball, and this plate of aluminum is 1/4 inch thick, so that's essentially flush now. Okay, now for the top section, I have this block here machined out. And there's a hole that matches the hole in the yoke. And then what this gets, and you can see it goes all the way through with a 1/16 of an inch hole here. I'll explain what that's for. What I did here is I made a pin. This is just a 1/4 inch bolt turned down with a 1/16 inch hole drilled through it. And what will happen is, you can see I have a cable here. This cable will essentially slip over this in here. And once you put that in there and drop it, but anyway, you solder that onto the end of that cable. Okay, so then the cable and that sneaks in there. And what I have here is a 1/4 inch OD spring that goes in there first. And with the cable on this thing, you slip it down through and stick it in there. So now we have a spring-loaded plunger. Now what that does is it comes up in here and it falls into that hole where that bearing is. You can see how much spring load there is on that. Doesn't need much. And now the thing is, this is locked. This collar will be cross drilled through the shaft on this thing, so it's everything's square. It'll be cross drilled and bolted solid to the horn. So when this up part turns, the horn turns all as one. But for this sake of showing you what happens. Now what happens is, this is your normal 30 degrees of travel with the steerable tailwheel. So the steerable tailwheel will be here. with the rudder pedals. It'll be tied in with a set of cables for the rudder. So then when you get to this point, that's the maximum travel of the rudder, 30 degrees. But on the ground, when you go to push on this, you know, this essentially up here is the top of it. It's kind of tough to do, but anyway, that bearing goes up and rides on top of this horn, this assembly now. And now, can't get, you know, tough as it is to work with one hand. I'm right-handed. Let me see if I can set this down. You can see what I'm doing. So, but anyway, this goes up around here, and when it gets up on there, now this horn is free to rotate. From here, it rotates around and around until this gets back over here. It's already locked, but see, it's free there. And as soon as I turn it a little bit, that ball bearing drops back into that groove. Ball bearing drops into there, and you're back to full steering again. Again, this is attached to this, so this whole thing, you know, swivels. Anyway, but that's how that works. So when you get over to here, then that horn can pop free, and it'll spin 306 degrees. But once it gets back into this position, opens, you hear it snap. Now you've got steering again. If this would stay still, you can see it goes like so. But once this gets back here, the wheel gets straight again. That locks, and you've got your steering again. So that's one of the little projects I was working on. And then what I had to do is I went to the bicycle competitive gear bikes shop in town and was looking for some cable and housing, which I did find. They sell this by the foot, and these cables come in like 6-foot lengths, and they come with your typical barrel connection on there, which I don't need. But what I did do is they have these pieces, they call them noodles. They go on the front and rear brake calipers for the typical brake pads that scrub on the rim. But theirs were too short. So I went and bought some 3/16 stainless tubing. And then this is some tubing I bought here, 1/8 inch, that perfectly fits inside this. And then the 16th inch cable perfectly fits inside that for alignment. But essentially, this mechanism, this open section here in the middle is where the horn's going to be. This is going to be hooked up kind of like this. These will be just at the ends of this 30 degrees of travel, so it'll be kind of like this. They're going to crisscross back here, back in this area. So if you can imagine, I'll set this down real quick here. Put these together so I can use both hands. Alright, let's get this picked up again. So this is going to crisscross like so. And what I'll do is I'll solder a fitting, a piece of tubing right here in the center of this will be soldered to that cable, and it'll hook through a pin that goes in here, and this will thread through it, and it'll have a set screw and clamp onto that. And then this will be put into a block of aluminum or something back here to hold these ends stationary. Now this can't move like this, because if it moves like that, your steering won't work. So this all has to be rigid to this frame. So I'm still contemplating on how I'm going to attach. Like I said, I'm going to crisscross these, drill it into a block. There'll be 90 degrees, exact 90 degree cross back here. And it's going to be attached into here somehow with this. And I may also have to come up with something to support these so these don't move. This is really tough stainless. I made a little tubing bender here, just some 3/4 inch that I cut some grooves in, put that tube right in the middle there, and then had this clamped in the vise. Held the tube with one hand and just run this thing around, and I was able to make this loop here. Again, this is all hard to do with one hand, but it was all one continuous loop like that. And then I just cut it up here. I have some extra of this lining sticking out. That'll be trimmed off later, but that's essentially what this is going to do. This will give me that 30 degrees either side. And this thing moves extremely smooth. I have my fingers in the way. But this cable glides through that perfectly. And then what will happen is the housing, this housing will go from there, and they need to crisscross and go up to the rudder horn, and then they'll be attached to the upper rudder horn like this. So when this pulls this way, it'll pull I'm getting up here. So when this pulls, sorry, this pulls this way, then this will pull across this way. But either way, and then with this will be pointing out to the back of the airplane. This is the front of the plane. The leaf spring hooks in right here, and then these cables come in. So, but it'll all be tied into the rudder horn with these cables. When one pulls, the other pulls back freely through, and then when the other pulls and it pulls back, it's going to be one continuous loop with a connection in the middle. So that's basically the setup for the tail wheel. Oh, then also this pin, there's going to be a cable, a piece of this cable in there, soldered to that pin in there. And then when this gear retracts, this thing moves just enough like this way that it travels like 3/8 of an inch, that where I can attach this right to this retractable linkage here. And then when the gear retracts, it'll pull this pin up, disengages coupling. So when it's up inside the airplane, your rudder's going to be doing this. This will be following your rudder, and the wheel will be free. It won't be up in there rolling this wheel, inside the tail area, because this will automatically decouple it. It's just a mechanical thing. This will be attached solid, and then when that thing retracts, it turns just enough off of this linkage that it'll pull this pin about 3/8 of an inch, and that pin engages by only 1/8 of an inch. So that's pretty typical of the tail wheels I see out there. So that's kind of how this thing works. And then this here system, remember when I was talking with the FAA inspector, he asked me if I had any kind of emergency gear down procedures, and I've always thought about doing this particular thing. What we have here is a tire inflator for bikes, again from the same bike shop, and these are CO2 cartridges. Nice thing with these is they're threaded. So I bought this valve assembly, bought a Schrader valve, and then bought these fittings. So essentially what this will be up in the front of the cockpit with me. This is an on-off valve. That's another reason I like this one, because you can turn it on and off. But when you need, what happens is if the motor fails to run, or the hydraulic pump fails, or the hydraulic line breaks and the gear won't go down, then what I do is you select the gear lever down, put this thing and tighten this bottle up until it punctures the tank, and then it will blow the pressure down through here to a T-fitting, and it'll go out to the left side of the wing and one out to the right side of the wing. Now I've made this valve, this fitting here, this is what I'm calling a shuttle valve. And what I have there is, where I must have dropped my bowl, here it is, sorry. This valve here is going to have, bore out for exactly a 1/4 inch ball bearing I just dropped in there. And what happens is this will be mounted onto the hydraulic cylinder, like this is the hydraulic cylinder. It'll be mounted onto the side of the cylinder that has to either push or pull on the gear to take it down. So this ball, check ball in here, this fitting will be mounted pretty much vertical, so the check ball's down here, and the hydraulics will come through here, go in and out of the cylinder, back and forth, free flow. It has to free flow. And then if the gear don't go down, then when I energize this bottle of CO2, it'll push this ball bearing up there, and it'll direct this fluid CO2 directly into the cylinder. Focus. This will direct it right into the cylinder and blow the gear down. Then the ball will eventually fall back here, but once the gear's down, it should be okay for a landing at that point. But if this was to be upside down and the ball falls down here, down to this side, when the ball falls in, it actually seats into basically the back side of these fittings. Is nice and beveled. The ball will sit there and kind of seal it. So the idea is we don't want this CO2 gas going out through the hydraulic line. If the hydraulic line's blown, you're just going to blow it out into the atmosphere. So this will blow it directly in. So that ball's got to be, my original idea was a little shuttle valve in there with a couple O-rings so it would kind of stay in position. But once you hit it with the CO2 here, it'll push it and drive that right in, and the fluid's on this side, but the CO2 can't come out this way when it shuttles. And then this is the check valve, so the CO2 and hydraulic fluid can't go back through. This is only a one-way valve, out that way, out this way. So the fluid can't come back up through here, the CO2 can't come back up out to this. But with this closed, it won't come out anyway. And this is a nice full swivel piece here. This is tightened down to the Schrader valve. The Schrader's still in there, but I'll probably take it out because I don't need it, because this thing was rated for like 4,000 psi, and these tanks will hold 800 to 900 psi of pressure, and there's two of them here. This is just a little foam pad. When you're using it on the bike, these things will get instantly freeze and you get frostbite from those things. So so you can carry one. I think one will be enough to blow it down. I went with a really small line just to save on volume, so you're not using all this up, filling all the lines. Now mind you, these lines will be extremely longer, you know, to get out to the wing. That's why I got 25 feet of it here. So, but the idea is the CO2 comes in through this check valve, blows the gear down, pushes the ball out, blows the gear down. And then to get it back in service, once you fix the problem, whether it's a motor, hydraulic problem, broken line or something, is when you put the hydraulic pressure back to it again, the hydraulic pressure will push that ball back down to this side, and then the operation will be back to normal again. So I made this. I got to make one more. It was just made out of a piece of 1-inch bar stock. I turned it all on the lathe, and then that ball bearing's inside there, like so. So that's what I've been up to this past weekend. I haven't been down to the airport at all. So what I need to do, I can take this down and put this back on, because we have another, the fly-ins this coming weekend at Port Meadville. Starts at 8 a.m., goes till 3 p.m., and it's supposed to be nice and like 80 and sunny on Saturday. So I got to take this, I'll get this thing drilled, pinned, and then I can actually take it back down to the airport, put it back on. And it'll still swivel like it did before, so it'll work the same as it did before. But until I get this rest of this system designed and hooked up to the rudder, it won't be steerable yet. So until I get this in and all working like I want it to, then that I won't be doing any taxi tests until that's in. That system I can put in anytime, because literally all I got to do is take. I need to get some 1/8-inch pipe to 1/4-inch hose fittings like these. These are 1/8-inch pipe. I might need 1/4-inch pipe. I think the cylinder's 1/4, so I got to go from 1/8-inch pipe to 1/4-inch tubing connectors like this. But I got to take the fitting off the cylinder, trim the line, and I'll use these push locks the same way, and put that in the cylinder, and it'll attach right here to the cylinder, or the hydraulics here. This attached to the cylinder. Hydraulic cylinder goes on here. So basically all I got to do is just pull one line, take the fitting out, replace the fitting, screw this whole assembly in there, and hook the hydraulic line into here, and I'll be able to test the system. I'll have to make up some jacks to jack the plane up now that it's all together with the wings on there. Get the gear up off the ground, and then I'll test out this system. And when I get to that phase, I'll show it. But in case one bottle doesn't do it, you can carry 2, 3 of these things in the airplane. But one of these bottles will fill a bicycle tire, one of those competition bikes, them $2,000 to $5,000 bicycles out there. This one, they run 120 psi of pressure in those tires, a lot of them, and it's probably 1 inch in diameter, but you're talking about a circumference of who knows how many inches. And these hydraulic cylinders in the wings, they're 2 inch in diameter with a 3-inch stroke, so they don't have a whole lot of volume there. But one of these tanks will fill a bicycle tire to over 120 psi. And I only need, this system only works on 300 psi on the hydraulics. So I think one will do it, but this is a 16 gram. They do make a 20 and a 24 gram, I believe. So, and then they make a little smaller one too. So I can always get a 20 or 24 gram if it needs just a little more. But either way, you can carry, half a dozen of these things. And if one ain't enough, you just shut the valve off, pull it off, change it, put another one in, turn it back on again until you get the gear down. So, all right, so that's going to be it, folks. Sorry, no plane video, but this is what I want to get fixed. This will be the biggest thing to do, is get this thing steerable, and then we'll see how that works out. But this is a pretty simple system, and I like the way how it turned out. So it's working exactly as I envisioned. And then this, of course, this will all be greased when it's put together. So, all right, as always, appreciate everyone taking their time to watch my videos. I will get this thing edited and throw it up on the YouTube tonight for you guys to see. I try to do these. I wanted to get this done yesterday, but the problem was I didn't have the tubing. The hardware store wasn't open till today, and I had to go buy some 1.5-inch stock. from the local supply house, so I had to get that today too. So I made this today, made these today, and fitted everything. So all right, as always, feel free to leave any comments, questions, concerns. I'll answer them as they come through. My video's been doing really well. A lot of comments. Appreciate everyone making the comments. Thanks for all the congratulations on the airplane. So I'll be working on my biannual flight review here in the coming weeks. But until I get this done, I'm still not going to be doing a whole lot of anything with it other than showing it up for the flying this weekend. I may take a little video this weekend of that so you guys can see how that turned out. So, all right, I'm going to go ahead and end this video here, and feel free again to leave any comments, questions, concerns, and I'll answer them as they come along, and we'll go from there. So until the next one, this is Dino Don out.